class. In this live class, let's look at this topic from when we stop. We have circle geometry. Then, in our previous live class, we have looked at some theorems under circle, which are very important if we want to solve questions related to circle geometry. First is to know and be able to recognize those theorems. So we have the first theorem that angle at the center is twice the angle at the circumference. So we can see that here we have a circle with center O. Then the angles obtained by a chord or an arc. So let's consider an arc here. Let's say we have arc AB. Then the angles obtained by this arc at the center of the circle. In this case, we have this obtuse angle AOB. Now is twice that which is obtained at the circumference. So let's call this the angle at the circumference. So angle at the center is twice that of the circumference. So if the angle at the circumference is x, angle at the center is 2x. So that's the first theorem. And also, we also have another angle at the center here, which is the reflex angle. And it has the angle at the circumference on this side. So now, if the angle at the circumference here is y, then angle at the center here is 2y. So that's what theorem 1 says, that angle at the center is twice the angle at the circumference. Now also, we have another theorem, the second one, say the angle subtended by a chord or an arc in the same segment are equal. So let's consider this as a chord AB. So the angles obtained by this chord AB in one segment, they are equal. So this angle is subtended by the chord AB. So we have it. Also, we have another angle subtended by this chord. So it might be more than 2. So the word subtend means form. So this chord is forming these angles at this segment. So the theorem says that all these angles are equal. And the proof is from theorem 1 here. If here we locate the center of the circle here, then we make a construction. Let's say the center O. We join line point A to O and also join point B to O. So this angle here will form the angle at the center. So if this angle at the center and this angle at circumference, so let's say the angle at circumference here is x, the angle at the center now will be 2x. Okay, and this is also angle at circumference to this angle at the center. So this is 2x, this is also 2x. This is 2x, this is also, sorry, this is 2x, this is x. So this is 2x, this is also x. That means angle at the center is twice the angle at the circumference. So this theorem is important as well for us to be able to solve related problem on circle. And we also have another one here. Says the angle in a semicircle is right angle. So we have the center of a circle O, then the diameter here passing through the center. The diameter divides the circle into 2 equal halves. So the angle obtained by this diameter is 90 degrees. So this angle is 90 degrees. So that's a theorem that angle in a semicircle, in other words, angle subtended by a diameter is right angle. So that is that. And let's look at another one. Number 4. We have this theorem, and the theorem says a line drawn from the center of a circle to a chord. Let's say we have a chord AB. So the line drawn from this center of a circle here to this chord. This line is perpendicular to the chord and also bisects this chord. So this point, let's label it as N. This means we have line AN equals to line BN. So that's the theorem. And we can join this A, O here. And when we join this line is a radius. Also here, this line is a what? A radius. That makes us to have two similar right angle triangle. That is, we consider this as right angle triangle. So if two sides are known, let's say the radius is given and this side is given, and we are finding the length of the chord. Don't forget that this chord has been divided into two. So A to N will be x, B to N also will be x. So once we are able to get x, and let's call this as 5, let's call this as 4. So assuming we are given the distance from the center to the chord to be 4 centimeter and the radius to be 5 centimeter, and we are finding the length of the chord. So just use Pythagoras theorem here and get the value of x. So then, since the length of the chord now is now 2x, so AB will now be equals to 2 times x. In this case, x is 3. On Pythagoras triple, 3, 4, 5. So it's a Pythagoras triple. When we apply Pythagoras theorem, we get 3. Then, that is how to handle such a problem. So it's also a very interesting theorem. Once we know the theorem, we know how to apply it whenever we see it in a problem. Now let's look at another theorem. And this theorem says that the opposite angle of a cyclic collateral are supplementary. We have a cyclic collateral, that is a collateral inscribed in a circle. So a collateral is a shape with 4 sides and 4 angles. And this theorem says that the opposite angle of it are supplementary. So if this is A, this is B. What it means that angle A plus B will add up to 180 degrees. That's supplementary angle. And if this is C, this is D. Also, angle C plus D is also equals to 180 degrees. So that's what this theorem says. And theorem 6 also, we have an extension of theorem 5 here. That is, exterior angle of a cyclic collateral is equals to the opposite interior angle. Now, let's look at this. We have this as a cyclic collateral, and if this side is extended, so this angle here, being the exterior angle, is equals to the opposite interior angle. Now, if this angle is A and this angle is B, what it means is that we have angle A is equals to angle B. So that's what that theorem says, that the exterior angle of a cyclic collateral is equals to the opposite interior angle. So these 6 theorems before we can be able to solve some interesting questions under this particular topic, which is circle geometry. Now, we also have some other theorem, which this one will be number 7 and is on tangent theorem. So, and this says that line drawn from the center of a circle to the point of contact of a tangent. Here we have center of the circle, and let's have this as tangents. So a tangent meets a circle at a point. So we have this line touching this circle at this point. So a line drawn from the center of the circle to the point of contact here is perpendicular to this tangent. Now, that theorem is somewhat similar to this, but in this case of theorem 4, it is a chord. But now, it's no longer a chord, but a tangent. So if we have a tangent AB, the angle from the center, a line drawn from the center of the circle to the point of contact is perpendicular to the tangent. So in another word, we can say that the angle between a radius and the tangent, because here a line drawn from the center to the circumference is a radius. So a line, the angle between the radius and the tangent is right angle. That's angle 90 degrees. All right. Now let's consider another theorem here as well. And that theorem, we call it theorem 8. It's also on tangent theorem, which is also interesting one as well. Let's look at it. We have this circle. Then from here, we have a tangent. And from that point of contact here, there is a chord. And the theorem says that the angle between this tangent and this chord is equal to the angle in the alternate segment. That means an angle is formed here by connecting two chords with this chord. So making an angle here, forming an angle on this side. So the angle between this chord and this tangent is equal to the angle in the alternate segment. So if this is A and this is B, what the theorem is saying is that angle A is equal to angle B. So the opposite direction is also true. Let's look at it on this side. We have a tangent, we have this chord. So angle between this chord and this tangent is equal to the angle in the alternate segment here. So if this is C, this is D. What it's also saying is that angle C is equal to angle D. So we have that also on tangent theorem. It's very important for us to master all this theorem so that easily we can solve problem related to circle. Now, let's consider the next tangent theorem. And this tangent theorem states that when two tangents are drawn from an external point, here we have a circle. And with this circle here, it has two tangents drawn from an external point. Okay, I can manage to draw it here. So we have this circle here. And with this circle here, we have two tangents coming from an external point. So let's say here we have these tangents and these tangents, and they meet at these points P, which is an external point. Now, the theorem says that these two tangents are equal in length. Not only that, here we have the center of the circle, which is center O. Don't forget from this theorem, a line drawn from the center of the circle to the point of contact of this tangent will be perpendicular to this tangent. So this is angle 90. Also, when we draw this from here, this is also angle 90. All right, and a line drawn from the center to the point P. So if we draw a line from the center to the point P here, this line bisects the angle between P. So it means that we have same thing here. If this is A, this is also A. And also bisect the angle at the center here. So this is B, this is also B. Bisect in mathematics means to divide into two equal parts. So bisect. So this angle here is being bisected by this line. So that's the important thing to know in this theorem 9. So when two tangents are drawn from an external point, the two tangents are equal in length. And we already established that the angle between the line from the center to the tangent is 90 degrees. So this is also 90 degrees. And this line here bisects the angle between the point P and also between the center of the circle. So thank you for your question. Someone is asking that we are not treating area of plane shape, but notwithstanding, for you to get area of a parallelogram, So area of a parallelogram, that's base times height. All right. So thank you for your question. Now let's consider this particular question here. As an example, let's solve some question on this particular topic. So if you are just joining us, don't forget to subscribe so as to be part of us in order not to miss our videos, and also share and like. Now, given this circle, let's look at this number one. Given this circle here, and we have these two tangents from an external point. We label this point as point P, and here is the tangent. And this point is labeled as X at the point of contact. This also is labeled as T. And an angle is formed here as well at the circumference of this circle. Okay, we are given the center hole of the circle, and this angle between P here is 60, and here is labeled as X. So the question says find the value of X. Find X. Now, when we consider this particular diagram, it follows from this theorem 9. So something interesting here, you can join these points and these points, and we can even draw this line from the center. This is a construction line, and since this line bisect this angle, 60 will be divided into 2. So this is 30 degrees, this is 30 degrees, making 60 degrees. And don't forget, the angle between the radius and this tangent is 90 degrees. So this angle between radius and tangent is 90 degrees. Now, something interesting is here. We have two congruent right angle triangle SOP or POS, and triangle OTP. They are both similar right angle triangle. And what happened there? This angle is already 90. And out of the angle in a triangle, 3 angles, 1, 2, 3. One is 90. So the 2 also will be complementary angle. That is 90 degrees. So the 2 angles here, this and this, should be complementary, right? So since this is 30 degrees, this angle now will be 60 degrees. Okay? Also, the same way on this side, this angle and this angle too should be complementary now. So this is 60 degrees. So now, making the total angle at the center here to be what? 60 plus 60. That make it what? 120 degrees. Now, that is that. Now, something will come to our mind as well, that it follows from theorem 1, just the same way we have it. But in this case, it is bent like this. So we have this like this, and this like this, and this is angle at the center now. Why is angle at circumference? Okay, and angle at center is twice the angle at circumference. So each angle at circumference is x. Angle at center will be what? 2x. So that is, what is it? So angle at the center is double that of the circumference. So yeah, we can say that angle at circumference that we are finding, or if you don't want to be confused, you can say that angle at the center, that's 120, right? So 120 degrees, angle at the center is equal to 2 times angle at circumference. Then divide both side by 2 to get your x. It means x is now equals to 60 degrees. So it's very easy. When you are solving question on circle, the most important thing there is for you to be familiar with those theorems. Okay, so once you are familiar with it, you can apply it to any given problem you have. So that is question number 1. Let's consider another interesting question here. And this question on circle as well. Very simple one. So here we are given this circle. Let's say this is question 2. We have this circle here. And we know, and the way it is given here, we have this radius and forming an angle as well at the circumference, also forming an angle here at the circumference here. And this angle here is given as 126. Then we have letter x here and we have y here. So the question says we should find x and y. Find the value of x and y. Now, when we look at this from the first theorem, so the first theorem is very important. That first theorem is very important. So if this is angle at circumference, it has its own angle at the center, which is this reflex angle. So this reflex angle is a corresponding angle at the center to this angle at circumference. So don't forget that angle at the center, let's label it as Z now. So Z here, though we are not asked to find, but that's the first thing we can see. Or better still, if you don't want to go that way, you can see that this shape is also a cyclic quadrilateral, which means a quadrilateral inscribed in a circle. And there is a theorem that says that the opposite angle of a cyclic quadrilateral are supplementary. So add this opposite angle together, A plus B will be equals to 180 degrees. So in the same way, we can get y directly. Okay, we can get y directly and say y plus 126 should give us 180 degrees. And we say this is opposite angle of a cyclic quadrilateral. So by taking 126 degrees to the right hand side, we have 180 degrees minus 126 degrees, and this gives us 54 degrees, right? So y is 54 degrees now. Okay, so once we get y to be 54 degrees, easily we can get x, because here y here is angle at the circumference, yx here is its corresponding angle at the center. Now these are what should be very clear to us. So when the angle at the circumference is up here, the corresponding angle at the center will be the obtuse angle, the smaller one. But when it is formed at this other side, its angle at the center will be the reflex angle, which is bigger one here now. Okay, so which means angle at center x now is now 2 times angle at circumference 54, which will give us 108 degrees. So this here we have an illustration to what we have from the circle theorem problem. So that is an interesting one too. Now you can see, look at some. So let's look at another one here. It's also an interesting one. Okay, So let's consider this as number 3. We are given this circle with center, and from that center a line is drawn. The center is labeled as C, then this is P, this is S, and here there is a line drawn here from this side. We have this line from here, and which is used to form a triangle here. And here, these two sides are equal from here. And this line here, there is another line drawn which is parallel to it this way. So it is parallel to this line. So let's look at that. And there's another angle here drawn. And this angle here is 56 degrees. So this point is R, and this is Q. So now, what the question asks us to find? The question says, so this is T. So RS is parallel to QT, okay? And line QR is equals to line RS, all right? So this angle here is 56. So the question says, the first one says, find angle SQT, and 2, angle TQT. So now, let's look at it and recognize. First, we identify the angle you have to find. SQT. So SQT, we are looking for this angle. So, and also we have PQT. PQT. So there is a need to construct a line from here, and also we are finding this angle, which is PQT. Now, when we look at this, actually there's something interesting here. This shape, which is QRST, is a cyclic quadrilateral. QRST, 4 angles touching the circumference. So this angle and this angle are opposite angle is cyclic quadrilateral. So here I can get this angle, which is angle QRS, is now equals to 180 degrees minus 56 degrees. And this will give us 124 degrees, right? So now, if this angle is 124 degrees, and they said this triangle here, we have two sides equal. So triangle QRS is, of course, will be an isosceles triangle. And that means this angle and this angle will be equal, which are base angle of an isosceles triangle. So this angle is angle X, this angle is of angle X. So by the time we add these 3 angles together, 180 degrees. That's sum of angle in triangle. That means x plus x, 2x, then plus 124 degrees should give us 180 degrees. And by the time we take 124 degrees here, it becomes minus. So that means 2x is now equals to 180 degrees minus 124 degrees. Alright, so 2x equals to 56 degrees, right? If I go side by 2, that means x here equals to 28 degrees, right? Now, if this angle is 28 degrees, it means this angle here too is what? 28 degrees. Now, let's look at something here from this place. There are 2 lines here parallel to each other. So, given this line, you can try to, if you like, when you extend this line is parallel to this line. And you know, when 2 lines are parallel, when the transversal cross the two lines, some things are equal. Look at this line QS as a transversal like this that crosses two parallel lines. So it crosses two parallel lines. It meets at this place and also meets at this place. Now here, this is 28 degrees according to what we have here. This angle too will be 28 degrees. That's alternate angle. That's like a Z angle. So it means angle SQT that we are finding. SQT now. So I can say SQT will now be equals to 28 degrees. Why? Because that's alternate angle. Alternate angle between two parallel lines. Two parallel line RS and QT. RS and QT. So just to state the reason. So this angle now is 28 degrees. That's alternate angle. Then we are almost done. Why? Because this angle now we can get it easily, which is angle PQT. So that can be gotten easily with just a step. And what do we need to do? Consider this line pass through the center, because they said it's center. PS is a diameter. So angle formed by a diameter is right angle. So all this angle here should be right angle, which is angle 90 degrees. So that means 28 plus PQT. 28 plus this angle PQT should be 90 degrees. So that means our angle, that's question 2, angle PQT will then be equals to 90 degrees minus 28 degrees. So just subtract. And this one give us 62 degrees, right? So that's all we have. We appreciate you for connecting. This is Master Teamwork class. Why not be part of us here by subscribing and also give a thumbs up, share this video, and join our membership package. And when next we meet, we continue. See you next class and bye for now.